Electromagnetic waves are electric and magnetic disturbances that can be used to transfer energy from a source to an absorber. Here is the electromagnetic spectrum. Light is an example of an electromagnetic wave, and electromagnetic waves are transverse waves, unlike sound, which is longitudinal. Electromagnetic waves are made up of oscillating electric and magnetic fields, and all electromagnetic waves travel at the same speed in air or space. Here is the electromagnetic spectrum. We can see that the spectrum is organized in order of decreasing wavelength and increasing frequency and energy. So from the left-hand side, we go from radio waves up to microwaves, then infrared radiation, through to the visible light, which is between red and violet, then ultraviolet waves, and finally the highest frequency of X-ray and gamma rays. Remember that the human eye can only detect visible light. The wavelength of visible light ranges from about 350 nanometers to about 650 nanometers. As electromagnetic waves can be used to transfer energy from a source to an absorber, you can use these waves from different parts of the electromagnetic spectrum in everyday devices and gadgets. As we can see here, microwaves are used in microwave ovens for heating food. And infrared radiation transfers energy from a radiator heater to its surroundings. Remember that these electromagnetic waves do not transfer matter. The energy they transfer will depend on the wavelength of the waves. This is why waves of different wavelengths have different effects. For example, radio waves are used to transmit sounds, whereas visible light can be used in cameras. Or ultraviolet radiation can be used in sunbeds, and X-rays and gamma rays are used for producing images of the body. Here is an exam question relating our knowledge of electromagnetic waves and the use of equations to calculate wave speed. A mobile phone gives out electromagnetic waves of a frequency of 900 million hertz. You have to calculate the wavelength of these waves. The speed of the electromagnetic wave in air is 300 million meters per second. To calculate this, we must remember the equation to calculate wave speed, which is wave speed equals the frequency of a wave times by the wavelength. However, we want to calculate wavelength, so we need to rearrange the equation, so divide both sides by frequency to give us the wavelength equals wave speed divided by frequency. Then we input the values from the question. So wavelength will equal 300 million meters per second divided by 900 million hertz, which gives us a wavelength of 0.33 meters. Electromagnetic waves act a lot like any other wave we know and can undergo refraction. Waves are refracted when they cross a boundary between two different substances at an angle, causing a change in direction of the wave. So here we can see a wave travelling from a less dense medium to a more dense medium. But the wave is not being refracted as it is crossing the boundary at a perpendicular angle to the next medium. So when the plane wave crosses a boundary at a non-zero angle to the boundary, each wavefront will experience a change in speed and direction, as seen in this diagram. If you enjoyed this video, make sure you give it a like. And if you have any questions, leave a comment below. Check out more of our content and remember to subscribe to our channel.